Just working through the skills test for trigonometry. Finding unknown sides, here's your angle. Oops, sine of 38 degrees, x over 7, 7 sine of 38 degrees is x. Check your calculators in degrees. No lengths, no units. You could say units here if you wanted. There's my angle, adjacent and hypotenuse. Make sure you put your degrees sign. Ideally I'd be keeping my equal signs aligned, but I'm a bit squished for space here. Finding unknown angles. Label your sides, choose your ratio, substitute your values. Inverse of the ratio just to get theta. You could simplify that fraction if you wanted, but you don't need to. Inverse cos of 18 over 24. We are in degrees now, so depends if they want degrees minutes as your answer. I've got 41.41. If I want degrees minutes seconds, use DMS. 41 degrees, 24 minutes, 35 seconds. Remember, if it's over 30 seconds, we round up. This one here, there's no right-angled triangle, but it's isosceles, so you can bisect it to get a right-angled triangle with a side of 3. Got adjacent and hypotenuse. Oh, look, we're cos again. Good habit to get into is getting degrees, minutes, seconds. 72 degrees, 33 minutes. Make sure we're rounding correctly. I think I might need to start taking an appropriate amount of space for this. We have adjacent and opposite. We'll be using tan. Substitute your values. Unknown is on the bottom. So we're multiplying by x and dividing by tan, 68.5. Next question. We have, okay, so we've got two unknowns here. I have opposite and I could get hypotenuse or adjacent. We just use tan. Let's get the hypotenuse. Substitute your values. 12.1 over n. Unknown on the bottom, so we're going to end up dividing. 58.19779. Now, I'm keeping quite a few decimal places there because your options for finding m are either to use Pythagoras or to use trig. Let's just use some Pythagoras there. So my hypotenuse I just discovered was 58 point. So I'm just keeping quite a lot of decimal places there. 12.1 squared plus m squared. I will need to subtract. You could have used the short side formula here, of course. M squared is okay, so I've given m and I'll give n is 58.2 units as well, because I'm giving them both to one decimal place. Going back to our questions here. True bearings are bearings clockwise from north. Since east is 90 degrees, that one's nice and easy. We put a T to say that's true. Northeast is halfway between north and east, so that's 45 degrees, so northeast is 45 degrees true. And this one here is all the way around to 180 and then back 17 degrees. Do feel free to use the calculator. We're subtracting 17. I've got 163 degrees true. Over here you can remember that west is 270, or we can go 180 and add this 80 degrees. So this will be 260 degrees true, however we work that out. Give the bearings as true bearings here. Okay, so remember, of course, that east and southeast, that's halfway. Southeast is halfway between south and east. East southeast is halfway again. That's how we've got that 22.5 degrees here. So south southwest, we've got 180 plus this 22.5. So that's going to be 202.5 degrees true. West northwest, might as well, what have we got? That's going to be another 22.5 there. 270 plus 22.5. And east, southeast, well, that will be 90 to there, plus the 22.5, 112.5 degrees true. I might pause at that point and do the next 3 questions on the next video.